How's it going, folks? This is the Deep Cosmos. I'm your host, Devin J. Barrows, and this is the first ever video in a hopefully weekly series called Astro News. I did one way back when, but now I'm hoping to be a bit consistent. Here to share the most current news in the astronomy world. I feel as though a lot of people, they don't really get immediate access to news that happens about the universe and our understanding of it. So I figured I'd make it more accessible to you all and not only give you the news, but try and give my perspective on it and try and change your perspective about the deep cosmos as a whole. If you want to be up to date with all things outer space and astronomy, please subscribe to this channel because we would be not only diving into the Astro News, but also diving into other concepts in astronomy where I give my perspective and hopefully give you all a deeper perspective of our place in the cosmos. So without further ado, let's see what's on the Astro News. So, we had a major breakthrough with exoplanets and their atmospheres. The most major headline that just came up was the first atmosphere detected on a habitable zone rocky world. This means that we are able to look into an exoplanet's atmosphere and actually detect what kind of atmosphere is on it. For some context, it said something about the habitable zone. That is a place in the orbit of a star where the planet is not too close to the star, where it is too hot and it will evaporate any chance of water. Not too far away from the star for the water to be frozen. It's just right. Some people call the Goldilocks zone. It's a bit of a weird name, but the habitable zone, that's the better name. Why are we so obsessed with water? Water is what we can think of as the main framework of life on Earth. We associate how life came to be on our planet with water. Of course, there may be other ways that life can exist out there in the universe. Life finds a way. But as of right now, water is one of the main things to look for and say, aha, there could be a chance for life. So now we're getting this look, and we're able to actually look and see what is in the atmosphere. So this data was taken of the exoplanet named LHS 1140b. A lot of these names for these kinds of objects are pretty obscure, but that is the exoplanet that they were looking at. And this was done through the Center for Astrophysics at the Harvard and Smithsonian Center. Researchers themselves are from Harvard, and their names are Robin Wordsworth, Gordon McKay, Professor of Environmental Science and Engineering, and Professor of Earth and Planetary Sciences, Colin Cherubim, who recently earned his PhD. It's pretty cool. So these are the three kind of leaders of this research expedition, and the atmosphere that they found on this exoplanet was primarily made up of helium. Now, of course, helium, is not the main atom in our atmosphere. In our atmosphere, the main element is nitrogen. And then next is oxygen. If you really were curious, it's around 70-something% nitrogen and 21% oxygen. But, Devin, I thought we breathe oxygen. We do. But most of our air, in fact, the air around you right now, is made up of mostly nitrogen. But our body and our lungs take in the oxygen from the air, transfer it into energy for our bodies to sustain life, and we breathe out carbon dioxide as a result of that interaction. Now, of course, I'm not a biological expert by any means, but that's how it works. We breathe the oxygen and take in the energy. So, although this atmosphere is primarily made up of helium, which is not something we breathe in, unless you want to sound like Mickey Mouse, then, it's not going to be necessarily useful for us, but this marks a very special occasion in the fact that with this kind of research, we can actually probe the atmospheres of other exoplanets in the future and gain a lot more information about them. This is very exciting, because if we can probe an atmosphere of an exoplanet and notice that it's made up of maybe nitrogen, oxygen, something pretty similar to our planet, it's in the habitable zone, and maybe there's evidence for some water, maybe. You get the picture? There could be a different Earth, right? Another Earth kind of planet that may have life on it. So this is very, very exciting and leading in a very great direction. And this happened just on July 16th, so this is massive. Another headline that came up recently was of the Perseverance rover. For those of you who don't know, on Mars right now, there is a rover that was engineered by NASA that was taken up and dropped onto Mars. It's called the Perseverance rover. And this article reads, NASA's Perseverance rover reads record of ancient Mars impacts. So this whole time that this rover has been on Mars, it's been maneuvering around the surface, and it's been mapping things, taking in some rocks from the ground, analyzing the rocks, and sending the data back to scientists on Earth for them to analyze and gather results about the planet's surface, its makeup, its history, everything about the red planet. And recently, the rover has passed through the Jezero crater. I'm not sure if I'm pronouncing that right, but it's the Gezero crater, where it's a structure called the Broom Point member. The sequence of layered bedrock is likely more than 3.9 billion years old. This means that this rock formation that they're seeing on Mars is almost the same age as Earth itself. And even back, and this is back when the planets were first forming. I would even argue that this is pretty damn close to when Mars itself first formed there. And the question is, okay, well, why, how did this structure be made, right? Where did this all come from? As this rover continues to explore, it's going to find out more about these structures. What we do know, and what we can kind of conceive from the data, is that this structure was made from multiple impacts. Mars, along with the other terrestrial planets, has been the battering rams of different objects as the solar system was first forming, especially Mars. There's a massive basin, the Isidis Basin, and this is a 1,200-mile wide basin that formed from a massive collision with Mars when it was first forming. And then after that massive impact and creating that massive basin, you had a second asteroid strike. Likely, we don't know for sure, right? But most likely an asteroid strike, forming the Jezero crater where the Broom Point is. Another thing about these rock forms is that they actually could have been formed from water and ice long, long ago. In the article here, it's saying how these layers form may suggest an interaction with water and ice. Several of the layers look like they may have been formed by fast ground-hugging debris flows. And we see this phenomena similarly on Earth with molten rock hitting water and ice. So not only do we have these formations from asteroid impacts happening on Mars way long ago, we also have the impact maybe of water and ice connecting with the molten rock from these collisions. It's crazy. A lot of terrestrial planets like Mars and even Mercury is a great example of this. They have a lot of battle scars of just impact upon impact upon impact. You can even look to our moon. All the craters, you can see it from just looking outside of the full moon. You can see the different shapes and colors and textures of the moon and see that it's been bombarded with all of these different kinds of impacts over its time. So now with this Perseverance rover, we're learning a lot more about the surface and how Mars came to be what it is today. So it's pretty cool. That's the next one I found the most interesting. Another one is right at home in my heart because it involves supermassive black holes. It's something that I'm very interested in. We have a headline here, and it's figuring out how supermassive black holes feed themselves. They have it in quotation marks. Oh, before I forget, the last article with the Perseverance rover was from NASA's Jet Propulsion Laboratory from the California Institute of Technology. This article on supermassive black holes is from the University of Montreal, or on the page it's Université de Montréal. So this article is talking about how supermassive black holes feed themselves. Let me slow down a bit. Supermassive black holes. These are gargantuan black holes that sit at the centers of galaxies. Galaxies are these essentially island universes, if you will, where there's billions upon billions of stars, each with their own systems. And again, in the center of those galaxies, there are supermassive black holes that sometimes can be actively feeding on things. It's not necessarily like a vacuum cleaner sucking in everything, right? But it's just things eventually swirling and falling into the supermassive black hole. There are some galaxies that have these objects actively feeding a lot. So they're what's called accreting, which is another word for feeding, a lot of the material at once. And there are some galaxies that are more quiet, where the supermassive black hole is not really taking in a lot of mass, kind of like our galaxy right now with our black hole at the center. We're kind of a quiet galaxy. There are other galaxies that have black holes, that are feeding at the centers. And this study was looking at how some of these black holes have jets. And what that means is you have the black hole in the center, and you have jets coming off from this end and the bottom end. These are the poles. And these jets spew out energy into outer space. And this study was trying to figure out how, after these jets spew out energy from the black hole accreting things, how does it reignite this process, this feeding process? You get this idea of self-regulating black holes. Long story short, they found out, after studying different objects with the very famous now James Webb Space Telescope, looking at the galaxy NGC 4696, they found that the jet would spew energy out into the galaxy. The surrounding gas around the black hole would be turbulated from this energy. It's almost like looking at a cloud of water vapor. If you were to blow on it, you would notice the hazy cloud kind of wisp, right? You get a hole from the air, and then it kind of be more wispy instead of puffy and soft looking. From this turbulence, it comes wispy, and then eventually slowly starts to spiral into the central black hole. The black hole accretes, and from this accretion process, it spews out more energy in outer space. That energy goes back into the gas clouds, and the cycle repeats itself. So this is pretty cool. This is another step into how supermassive black holes feed. What's important about this is supermassive black holes and their feeding process affect the entire galaxy. Sometimes supermassive black holes, when they feed, they can totally disrupt star formation in the galaxy. That's a big no-no, because if you don't form stars, there's not energy to be permeating around, and there's less chance for other things to form, planets and systems in general. And then you have things where sometimes certain blasts from the actively accreting black hole can also boost star formation. We call these starburst galaxies, actually. It's kind of funny enough, named after the candy, but also just, a burst of stars from the energy from the supermassive black hole. And if we can learn more about how the black holes at the center of galaxies affect their environment, we can also get a structure or more evidence for how they formed, how galaxies formed, and how black holes even work in the first place, because they're still very mysterious objects. That's actually something I'm really interested in studying someday, and hopefully I get a chance to do that. So that's another one. Anyway, that's a brief rundown of what's going on. And this is the first of hopefully weekly videos where I catch you all up on what's going on. A lot of these articles I'm getting from the AAS, which is the American Astronomical Society. And they have this news website where you can go look at articles. But I figured it'd be more concise to take what I find important, give it to you all. We can discuss more from there. So this is pretty free-flowing, and it's not really going to be edited too much because I'm just kind of talking about astronomy. But otherwise, if you have any other thoughts, let me know in the comment section below. Which of the news headlines did you find the most interesting? Which topics do you want me to focus on for next time? And maybe even just some ideas on what you think could come out of this research. That's all I have. So long, folks. Think deep.